Okay, we're starting now. We're live. Hi guys. So like last week you remember last week we discussed about the introduction to AI and what AI really meant and what was involved in it. But today we're going to see a continuation to that introduction, basically speaking about how it is in development, what are the approaches we usually see in development, and there's a sharp contrast we'll be seeing soon, because when you see it in academia and what you see in the real world or the industry. So we'll take a look into that today. So first thing is how we make it. This is not just for NLP, but also for other forms of AI or even in other uh, pro- uh, programming issues. I mean, you would see that there's two approaches. One is a model first approach. One is a problem first approach. What's a model first and a problem first? Well, in academia or in universities or in teachings, you have a model and you're like, okay, you know what, I'm going to use this model to solve a problem. But that's not a real world problem. That's just a problem we're making so that we're able to use this image or learn how to use that model, particular model. So as you can see, it's usually refined. It's like well thought out to teach. It's used for teaching, and you have documentation and things like that. But the minute you go to the industry or you start working in the real world, an investor probably would give you an issue, and he's like, I want this product to be there. Now, for this product, you have to start planning out, thinking where I'll get the data from. I don't have a model, pre-built model, so I have to build a model. What that involves, and all of a sudden, anything you learned in academia doesn't make sense. Like you're like, wait, I never learned how to make a model in the academia. So that's what we wanted to cover, and that's actually one of the approaches we're going to be taking with this whole chatbot thing, where we are going to collect data, scrape data, like how they would do in industry, create a model, and then even have an opportunity to see where data bias comes in, how to fix issues commonly seen with model making or like when compiling a data set. So th- that's something we're going to do for the NLP project in Tech Lab right now. And as you can see, that this is the main difference between a problem first or a model first approach. Problem first is the real world. Most of the real world issues you would solve, like you'd create a new product that would be to solve a problem. But in academia, to learn, you always use a model first, and you have documentation, things like that. And the the whole transition thing. Now, how do you do the transition? First thing is you need experience. It's because out in the real world, you won't have a reference to look at. So you're relying on what you have experienced, what your team's experience is. You're like building upon each other's previously gathered knowledge. So the only way to get that is to do projects. And as university students or as everyday people, how would you do it? You would either do individual projects, which is very common, and you would, for in our case, for Heritage students, we would do it via the tech club too. So Yes, on a personal level, even from the tech club, we would encourage you to go out, search out for projects, look at things that interest you in your field, and try it out. Make those projects. Try to take what is good from those projects and make something new, or probably build on top of it. So it's not like don't reinvent the wheel, but at the same time learn how it's integrated, so that you're not missing out on the fundamentals. So you know how to build something, so you have that knowledge, but at the same time you're not reinventing the wheel, just doing what others have already done and wasting time or resources. So that's the thing. So at Tech Club, we're planning to take a mixture of model first and problem first approach while building this, because we're using the GPT to model, but at the same time we are going problem first because we want to tailor it specifically to what our projects are, what our interaction with the community is based on all of those things. So now I'm gonna give it to Anchal. Mm-hmm.
The model first approach is where you take a model and you use it, a pre-built model, right? So thing is, there's been a mixing of these two approaches recently, as even in the industry they use models that already exist. So like this, that would come under cognitive engagement, any form of AI that uses, that engages the users. So, moving on from this, we're going to talk a bit about the applications of AI, and we'll have a look at what kind of things can be done and what are already being done with the use of AI. So, the first example that we have is finance. Again, like I said, AI is basically glorified automation. So, it's not necessarily something that emulates humans, and we can see that as we move on through these applications. So in finance, an example of the use of AI could be a new storing system, storing a vast amount of price and trading data in its computer. And by tapping into this reservoir of information, it'll make assessments. For example, it may determine the current market conditions are similar to the conditions 2 weeks ago and predict how share prices will be changing a few minutes down the line. So, this is what I was talking about when I mentioned the stock market prediction. So this will basically help to take better trading decisions based on predicted market prices, and the predictions are based on large amounts of data that have been stored. The second would be agriculture. So, like, here's an interesting fact: the world will need to produce 50%, not like it's 50% more food by 2050 because we're literally eating up everything. The only way this can be possible is if we use our resources more carefully. With that being said, AI can help farmers get more from the land while using resources more sustainably. Blue River Technology is a company that has recently developed a robot called See and Spray, which uses computer vision and technologies like object detection to monitor and precisely spray weedicide on cotton plants. So this is another use of AI that we see, and this basically helps in the agricultural section to manage our resources effectively. So then we have gaming. This is probably my favorite application of AI. Everyone's probably heard of AlphaGo, and for those who haven't, it's a software trained in the game Go, which simply can be described as a complicated version of chess. It is like the software AlphaGo has defeated the world champion in the game, and DeepMind, the company that made this software, is has made another software after it called AlphaGo Zero, which defeated its predecessor in an AI face-off. So, unlike the original AlphaGo, which DeepMind trained over time by using a large amount of data and supervision, the advanced system, AlphaGo Zero, taught itself to master the game. It taught itself. Um, so, other examples of AI in gaming include the FPS game called First Encounter Assault Recon, where the opponents in the game are unpredictable and they learn from their movements. And as you move through different levels of the game, they get harder and harder to take down because of their unpredictability. So then we have exploration. Exploration can include both space exploration and underwater exploration, extraterrestrial exploration, and so on. Autonomous vehicles being one of the biggest helping tools in exploration, and that also comes under the travel thing. So, autonomous vehicles are a very big part of exploration to places that humans can't reach, such as other planets or underwater. And AI really helps find, or like AI really helps the goal of exploration by having these vehicles collect samples or understand their terrain and move around with a visual map, create a map, and so on using like artificial intelligence. Um, so these are a few examples of how AI can be used in the real world and are currently being used. We'll see as we move on the risks of using AI in the real world.
So, okay. So risks of AI. We have seen people when we discuss about when we talk to other peer researchers and people, they always say, "Oh, there's a risk to AI." You go to the everyday people, they think about AI, but the second thing they're like, "Oh, what if something like Terminator happens, the movie Terminator?" It's I mean, we sometimes smile at it, we laugh at it, but at the same time, we need to accept the fact that there are risks to AI, and it's not always all bread and butter as we always seem it to be. The immediate risk, the most immediate risk, as we all know, is job automation. I mean, AI is basically some program that is capable of doing a task really well, and it's capable of repeating that, like repeatedly doing that task, continuously improving on each iteration as it goes, or each time it finishes it, it learns something from it and keeps improving itself. And this kind of moves into the territory of job automation, and people start to lose jobs. I mean, when we talk about people starting to lose jobs, the main sector that gets affected, I would say, is the sector that does repetitive work, or like the working sector. Now, there are tasks that would be, for example, let's take Tesla and let's take another conventional car manufacturing um, factory. In a traditional car manufacturing factory, we would have workers on the line working in long lines to create a car. They work in synchronization. And it would take them around 6 hours, 8 hours to create a car. But with Tesla, because it's automated, Tesla can be the main body frame on a single line, can be often produced in 2 to 3 hours. It's quite fast. So this kind of replacement is the most immediate risk that people voice out and they show out. The other risks of AI happens to be, what about people ask, what about privacy, security, and the rise of deepfakes? What are deepfakes, by the way? They are when we pass the uncanny valley, or we pass the point where we cannot differentiate whether it's an AI or whether it's a human, whether it's something created or whether it's something real. I mean, as it's written over there, no one knows what's real and what's not. So it really leads to a situation where you literally cannot believe your own eyes and ears. It's quite true. I mean, there's actually an interesting example is if you guys take a look at MIT's Introduction to Computer Science course, their beginning, the introductory video. The first part is actually introduced by Barack Obama, but funny part is he never introduces the course at any point in history because it was a deep fake or an AI that basically mimicked him so well that until David Mellon actually tells you that it was generated by an AI, you would believe it's actually the um, real deal. It's really Barack Obama who actually introduces the course, and it's quite astounding when you see through that. So it's one of the risks of AI. AI is getting too good to the point where you can't differentiate whether it's a human or it's an AI. This is especially common. We could see, not it's not common, but we could see this in chatbots. Like a lot of chatbots you interact with are not actually humans on the other end, but rather it would be a AI, a program designed to assist with you based on context. But you would be like, oh, it's a human. I'm getting help from a human. And while it's financially profitable for the company, I mean, it's kind of like cheating the user. So that's where the controversial topics and questions come in, like, and people start discussing. The other risks of AI include the bias and widening of socio-economic inequality. What do I mean by AI bias? An AI is only as good as the model it is trained on, or the model it has to make decisions on, or based on. So we are humans and we are biased. There's no question about us being unbiased at any point in life. We always have our preferences and our dislikes. So this can translate eventually into an AI model, but then it might not be apparent in the beginning, but down the line it can be a sizable difference, and it can be a biased AI. when it reaches that point, you're like, how do I negate this? So that's a risk. So we have an example. There was this Twitter bot that was once there, which it was allowed to learn on tweets, but quickly became a racist program. So it's just one example of what can happen. So, and the main problem is there isn't a common goal from everyone to be like, okay, we need to avoid this. End of the day, AI's research is often funded. A part of it, a huge part of it, is often funded by the private sector, and they go for profit. So as long as they make profit, everything else is okay. So it's like that quote. If we can do it, we should try it. Let's see what happens. And if we can make money off it, then might as well do it a bunch of times and make more money off it. And it's quite that's the mentality, and it's not just unique to technology. So it translates. That's another risk of AI. And then we have what are the bigger questions that people pose over time. What happens when you start applying AI to weaponry or autonomous systems for weapons? Interestingly, Musk says that AI is more dangerous than nukes. And there was a backlash on Twitter based on that. But surprisingly, not just about him, but it's an interesting topic he brought out that day, because AI is really good at repeating tasks, finding the best possible way to do a task, and autonomous weapons, when they're equipped with it, they become ideal for tasks that require you can't risk a human operator's life, but AI would be expendable at that point, and it can do it really well. So it it crosses on to the point where we start thinking about it. And yeah, we might be like, no, that's not going to happen. We have international ethics in place and things like that. But end of the day, ethics are not legally binding in any way. So in reality, it's dependent on what the financial motive behind it is, because war begins when there is a financial motive behind it. So the funding for AI for war kind of crosses on those lines. So it's an interesting take. It's one of the risks of AI, but there have been a lot of movements to mitigate this. So hopefully they kick in place and we do not face the end of the world. But we are way far off from reaching that point, because at this point AI isn't as developed as we would imagine, but we're certainly headed in a direction where we can get there. But that's again a topic for discussion for another day. And we for myths, I hand over to Aanchal.
Right, so here are a few myths that we're going to talk about that people generally believe to be true about AI. First one, AI and ML are the same thing. So this is a very common one because artificial intelligence, machine learning sounds like the same thing, right? They both are usually referred to in the same context in media and so on. However, no, they are not the same thing. Machine learning is a subset of artificial intelligence, and we talked about this in the previous session. So let's just go over this one more time. Artificial intelligence can refer to anyone it can be an attribute of a software, and it is also a field of study in itself. Machine learning is a field of study that comes under artificial intelligence, and it's a process that is used in the development of an artificially intelligent software. So it's not the same thing, and hopefully I have explained it well enough for you guys to understand why. The next myth that I'm going to talk about is intelligent machines learn on their own. So this is clearly not true. A finished machine learning product does give the impression that it is able to learn on its own. However, experienced human data scientists have to frame the problem, prepare the data, determine appropriate data sets, remove potential biases in the training data, and most importantly, continually update the software to enable the integration of the new knowledge and data into the next learning cycle. So it does not learn on its own. It does require human interaction, and it does require human specialization and expertise. So let's talk about the next myth we have. AI is 100% objective. This is clearly not true, as we've talked about in the last session, and as Benjamin has just mentioned. Since AI is based on data that is in some way influenced by humans have intrinsic biases. They do tend to favor one thing over the other, and this shows in any data that has been influenced by humans. And so, like as a result, any AI that is based, or like any AI that is based or trained on data that is somehow influenced by humans will be biased as well. No matter how inconsequential, it will be biased. Maybe it'll like cake over tart, it doesn't matter. But it will have some sort of bias. Um, and like for the next myth, AI software is pricey and hard to use. So this one is historically true, but not so much now. Because AI as a concept was like is relatively new in the field of computer science. Um, well, not as a concept, sorry. AI in practice is relatively new in computer science. It is logical to think that it will be pricey and hard to use, hard to acquire, find the expertise to actually run it, and so on. However, there's so many solutions these days that don't really require all the effort that used to be required to run anything AI. So these days, many tools are increasingly available to business users and don't require Google-sized investments. And the business value lies in using existing AI tools. So you don't have to come up with completely new tools, which is where all the money went into. You can use existing tools that are made to be easily usable for users and customers and even businesses. So these are a few myths I tried to cover, and we'll be moving on to the tasks that we have for the project that we're going to start. We're not going to go over this like a lot right now. We're just going to leave it here for you guys to check out, like in case you want to do a project yourself. But we'll go over this with anyone who's interested in doing the project with us in the WhatsApp group. We'll put up a link in the Tech Club WhatsApp group, and we'll talk to you in the ML chat. See you there.
Thank you guys. Thank you for attending. Bye.
See ya.
Okay, bye.
So yeah, that's the
Not
end of
you,
that.
not you, not you. Okay, okay. So we're
Stop
done.
recording.
Huh?
Yes.
Recording got, yeah?
You guys like
Yeah, I stopped. I stopped.
over?